Around the world, there are factories making everything from bikes to biscuits. With mega machines mass producing and highly skilled workers handcrafting. They are the products we use every day. But have you ever wondered how to make a state-of-the-art fire extinguisher? How to keep blue cheese tasting ripe? Or run words through a stick of rock? Well, sit back as we go behind the scenes on the production line. Oh, we do love to be beside the seaside. Millions of us enjoy a trip to the coast each year. And of course, no visit is complete without a sweet treat. On a sunny day, the humble stick of rock is a firm favourite of young and old. This boiled sweet has been popular for hundreds of years. And for one manufacturer of this circular sugary sensation, business is booming. Satisfying our seaside sugar cravings, John Bull produces over 40,000 sticks every week. That's 6.5 miles of rock. But what exactly is rock? Well, it's just sugar made into solid sticks. Every dentist's nightmare. And to satisfy our sweet tooth, the factory gets through 25 tons of sugar and 20 tons of glucose every week. So, let's get rocking. The first stage is the cooking process, which happens here, in the boiling room. It's hot and sticky work. Roll it.
So the first part of that process is the water, which is 4 litres of water we pour into the pan. Then we'll add a 25 kilo bag of sugar.
A toffee boiler mixes it all together by hand, just like they've been doing for hundreds of years. There's few labour-saving devices here. This copper pot conducts heat 5 times better than an iron one. That's 20 times better than steel, making sure the heat spreads more evenly.
Once he's mixed the process up, we put the lid on and we switch the pan on. Then we can add the glucose. Then we leave it to boil up to 140 degrees.
Glucose is a type of sugar used to thicken the mixture.
It's important you get the mixture right and the process done in that order, otherwise you end up with too much glucose or too much sugar, which then it becomes lumpy, so we have to get it right.
It takes 40 minutes to get the mixture hot enough to make rock. One batch of mixture makes 600 10-inch sticks, and they make 14 batches a day.
I've never known anything else. Me and my sisters, we've always known this. To me, it's just normal. It's just, probably not normal to a lot of other people, but to have a sweet factory.
It's a process that James has grown up with. He's the 4th generation of the family to work in the rock business.
Yeah, very proud of what we've achieved over the years and to keep it going on, over 100 years.
And Dad, Trevor, must have a sweet tooth too.
I am pushing him to be here. He just wants to be here. It's all he's ever known, so obviously he wants to come in and work every day.
Trevor's granddad, Ernest, opened an emporium of rock in 1911, and his dad, Leonard, worked there too. Today, they're still using traditional methods. And the next stage happens at the cooling table. This bit of kit has cold water running through it to cool the sugar mixture down to a workable temperature.
This is still about 130 degrees. We get it on the table, cool it down. What they're going to do at the bottom left one there is now add the colours.
Colouring is added to some of the mixture that'll be used later to form the lettering and casing in the finished piece of rock. Making rock is a race against the clock. As the mixture cools from 130 degrees, they have only 20 minutes to finish the process before it starts to solidify. Each panel of cooling sugar mixture is destined for a different part of the finished stick.
See the underneath of it, it's starting to set and it forms a shell, like glass. So just folding it over, and they'll keep doing that at regular intervals to prevent it setting. They'll be down to a temperature of about 80, 90 degrees, because they can start handling it properly now, and we can tell the temperature by touch.
The red and blue parts are going to make the outer layer of the rock. The rest of the mixture is going to form the centre of the rock, but it needs to be flavoured and aerated first. It's put on the pulling machine to change its texture.
The process we've got now is we're actually adding air to it. We're fluffing it up, and you've seen it go white. That's a reaction the air has had with the glucose and the sugar. So while it's doing that, it's added the flavour. So where you saw him pouring the liquid on, that's the flavour. This is strawberry flavouring.
The team use over 30 natural flavours. Now that's what I call eye candy. Once the mixture's cooled, it's time to prepare it for assembly. For anyone yet to enjoy this sweet treat, the lettering runs right the way through the middle of the stick. But just how do they put the letters in? Well, the secret is a feat of confectionery engineering. Thankfully, there's an expert on hand willing to tell all.
So all the lettering that goes in a stick of rock are made by hand. Andrew's been doing lettering for 8 years.
It takes a real craftsman to get the letters right, as the coloured rock and its fillers can be up to 6 feet long.
So he stretches it out, puts it in the white blocks. They prevent it going flat.
Each letter is built separately. Thin strips of the mixture are cut to length and fitted together, so the visible ends form the letters.
Everybody has their own letters they don't like making. So my letter is a Q. I don't like making a letter Q.
If I had to choose, I'd pick Y probably, because you've got to make 2 letters at once. You've got to make an I, and then you've got to make a C.
Seaside rock dates back to the 19th century. Some sources say a Victorian character called Dynamite Dick was inspired by a fairground rock and took the idea back to the seaside. Rock enjoyed its heyday in the 1950s and 60s, when seaside towns were at the height of their popularity. Although rock is still a firm seaside favourite today, here at John Bull they're always looking for ways to maintain its popularity.
We also do a lot of wedding rocks, so we had our own rock once we get married as well. I wrote it myself.
If you look at where we are now, we're nearly at the end of the lettering. So the red's the letter, the white is the filler and a space in between the letters.
While Andy has been handcrafting the lettering, the casing is being prepared, ready to wrap them.
The red, the white and the blue is going to be the outside of the rock. When they've stretched it out, they'll cut it, and they'll do that about 4 times till we get the right size that we need for the actual rock.
Andy then stretches the letters out and covers them in a sheet of white rock. Then it's ready to be enclosed in its coloured casing.
So we've got the layer of rock between the lettering and the outside of the rock, so that when we put it onto the casing, there's actually a buffer between the letters and the casing.
This large lump of mixture, called a batch, weighs 40 kilos, and it takes 2 people to carry it to the next step.
It's heated, so the rollers are going round, and while it's spinning it, it's softening it up. So what Jason's trying to do now is trying to drag it out so we can get it down through the rollers. And what Tom's doing at the end, he's pushing the rollers in. So it's putting pressure actually on the stick of rock to narrow it off. It is quite a difficult job to learn to do and to get right. So he's going to tear the end bit off. That'll be used as broken rock. Got it through the rollers. Now, the rollers are dictating the width of the stick, not the length. So they're going to stretch this out the length of the table.
The 40-kilo batch is painstakingly stretched into a whopping 150-metre length, then cut into 10-inch sticks.
So if you look at it, on the top of the scissors, it doesn't actually cut it, it cracks it.
Cracking it and not cutting it prevents it from shattering.
The next half an hour, this will be getting wrapped. Because of how big they are, they're still quite soft inside, so they have to be left to set fully. When we've wrapped them, they'll be put in the baskets, and they'll stay there for about 24 hours. The smaller sticks, they've cooled down straight away, so they won't lose the shape. So they can be boxed and sent ready to go out today.
It looks easier than it actually is to wrap the rock. There is a technique, and everybody has a different way of doing it.
Okay, so now we're approaching the final part of the process. While they're actually counting them out, they're checking each stick as well to make sure they're not broken. And there's about 144 in a box. And if they lose count, they have to start all over again.
The sweet taste of success for over 100 years.
I like rock.
If you're ever unlucky enough to find yourself fighting a fire, your best chance of getting out safely is with a fire extinguisher. You can find them in homes, hotels and offices around the world, and many of them have been made by Britannia Fire. Founded by Roger Carr nearly 30 years ago, they're one of the biggest producers of fire extinguishers in the world.
Well, in my company, I'm known sometimes as the Nutty Professor. So I started off servicing fire extinguishers in the very early days. After 2 years, I invented my first product called the Norfolk range.
Roger was one of the early innovators of the seize and squeeze handle that is still in use today. Fire extinguishers are pressurised containers that pump out liquid, foam or chemicals to extinguish a fire. They consist of a metal body, a pressure gauge and a hose. Britannia produce 80,000 fire extinguishers every year, including the classic steel design that's changed little since the 30s. Steel is easy to shape, strong and is relatively cheap. But Roger has invented an entirely new design that is taking the world by storm.
This is the only product in the world of its type. And the product can be completely recycled, which is very important in today's world.
His revolutionary P50 is unlike any other fire extinguisher. It's made almost entirely out of plastic. Making a fire extinguisher begins with manufacturing the cylindrical body. This one's made of hollow plastic, then strengthened.
So we have a recipe that's secret to ourselves, which is a part of the patented product. It creates 5 layers to the bottle, and that gives us a uniqueness.
"614 grams of plastic pellets are melted down and poured into a steel mould. Then high-pressure air is blown into it to expand it.
So this is a cylinder that's been blow moulded It's around about 50% lighter than a steel extinguisher.
Not only is it lighter, Roger's plastic design is stronger and requires no annual maintenance, making it cheaper.
And none of the product is actually wasted. This goes off to production, and the waste gets reground and is used again.
So that a handle can be attached to the cylinder later, a nickel-plated brass flange is added.
So here we now have the cylinder with the flange applied to the actual body, which is now going to go onto the machine to be spun.
Now it's wrapped in a heat-resistant fibre to make it strong enough to cope under high pressure. I could do with a quick spin myself. This fibre is usually found in flak jackets and stab vests and is 5 times stronger than steel.
Without the fibre being applied to it, has a burst pressure of 4 to 5 bar. Once you apply the fibre onto it, it has a burst pressure of 80 bar. It's our baby.
Every cylinder is then pressure tested to make sure they can store their contents safely at high pressure.
We place it into the testing chamber and we hold the test pressure for 25 bar. And that takes about 30 seconds.
Britannia know that their cylinders can take up to 80 bar of pressure before they explode.
As long as the cylinder remains in excess of 22 bar, we get a pass rate.
Now it's time for a makeover. First, an outer cylinder is added.
This is where we apply the red jacket. I'm sure it'd be very nice to have gold cylinders out there, but we have to stick to the EN regulations, which say every extinguisher should be red.
All fire extinguishers have to be painted regulation flame red so that they can be found easily in an emergency.
We are doing around about 200 units a day. These guys are working really hard at the minute.
So the all-important instructions can be printed on the side, the red cover has to be heated.
Jeff is flame treating one of the cylinders now before we screen print it. So we didn't do this, the ink will simply slide off the plastic.
It's then screen printed and UV treated so the ink doesn't fade. Next up, a handle and a pressure gauge are added. The easy-to-use squeezy handle is quick and simple, just what you need when the situation is heating up. On to the final stage, adding the all-important extinguishing agent.
So here we are filling the P50s now. This is Lee.
Domestic fire extinguishers can be filled with 5 different fire agents: water, chemicals, CO2, dry powder, or foam. Fire regulations say which one you need to put out different types of fire. This P50 is being filled with foam, which can put out fires caused by wood, paper, textiles, solvents, and chemicals. 6 litres of aqueous film-forming foam, or AFFF, are put into the canister. This smothers fires with a layer of foam that starves it of oxygen. Next, to create the pressure to propel the foam, gas is needed.
The gas we use is 95% nitrogen, 5% helium.
The helium gas is added to help check for potential leaks.
Helium's a searching gas. We've put the unit into here, it's sniffing for the helium. It's trying to find the helium. Helium will find a way out, it's an escaping gas. It's no laughing matter for us. The last thing we want to do is ship a unit from here and it leaks. From here, we apply the gauge cap covers and also the hose.
OK, now it's time to fight some fires. Simply squeeze the handle to release the foam and sweep from side to side. Roger has a lot of experience.
I'm now at the age of 73. I hope to continue for at least another 10 years. My passion's been in fire.
Barbour's iconic wax jackets are designed for the rigours of outdoor life, but are equally at home in the city. Originally made for the practicalities of country living, they're now a luxury brand favoured by celebrities and even royalty. And after 125 years, they're still made by the same family-owned business.
Well, we're one of the largest employers in South Tyneside, and we employ almost 600 people on this site. Well, I'm 5th generation in the business. I mean, I've been walking into the factory since I was a child. There are generations, there's grandmothers, mothers, daughters who work here. So, yeah, immensely proud.
The Barbour story began in 1894. Helen's great-great-grandfather, John Barbour, imported oilcloth originally used for ship sails and made waterproof coats for dockers and seamen. Coated in linseed, the linen oilcloth was thick and weatherproof, but it was heavy. When waxed cotton was perfected, J. Barbour & Sons jumped on board, making wax jackets. Perfect for all kinds of outdoor pursuits from shooting to horse riding, thus creating a successful international brand in the process. Today, Barbour make up to 12,000 wax jackets a year. And it all starts with the waxed cloth, which they get from companies like Halley Stevenson. Waxed cloth is cotton soaked in paraffin or beeswax. Before it becomes the unique waterproof fabric used to make jackets, it starts life as an ordinary cotton. The first part of the transformation is to prepare the fabric for dyeing. As cotton is a natural fibre, they burn off the surface fluff before it's washed and dried.
So our capacity for this dye house will be around about 40,000 metres a day.
It's James's job to dye the fabric with Barbour's signature colours.
Most of what we do is existing recipes, dye recipes and waxing recipes that maybe go back 35, 40 years. So we choose a combination usually of 3 dye stuffs, which we'll blend together to create a shade. And this process can take about 2 weeks. Once the shade's established, then it's good to go for bulk.
Next, dye is added to the cotton on the jigger machine.
You can dye anything from 50 metres up to 3,500 metres.
The temperature of the dyeing process is closely controlled. It starts at 30 degrees and increases up to 95, so the dye goes on smoothly. It takes an hour and a half to dry the dyed fabric before it's ready for the all-important waxing. Now, the essential part of a Barbour jacket, the waterproofing.
So here we're taking the dried fabric and we're actually putting it through a bath of molten wax at about 100 degrees centigrade. We blend a combination of petroleum jelly, a candle wax, beeswax and a little bit of refined oil.
The cotton is left for a week so the wax can properly soak in before it's given a thorough inspection.
You can check the colour continuity, the correct wax add-on, and that's it ready to go down to Barbour.
Back at the factory in South Shields, it takes 36 people to make just one waxed jacket from start to finish. The first step is to cut out the pattern. The process begins when garment patterns are overlaid across the waxed cotton and cut out by hand. 2 metres of waxed cotton are used for each coat.
So Dan here is one of the cutters, and he's cutting out all the individual sections. We make about 650 a day, about 3,000 a week. That blade is very, very sharp. It would cut your finger off.
Although that hasn't put Dan off.
I must like it because I've been here for 18 years.
People who want to start in barbers will stay for quite a long time. It's a nice family business and people tend to stay and feel very comfortable.
After the different parts are cut out of waxed cotton, they're each lined with Barbour's trademark lining.
Now we have about 8 different tartans, which is exclusive to Barbour.
Tartan is used to line the jackets, as the Barbour family can trace their roots back to Scotland.
This green tartan that's on the table at the moment is one of our most popular. My favourite, I would say, is the green, because I like the green.
It takes 49 pieces of fabric to create the Barbour Classic Bedale. Designed by Helen's mum, Dame Margaret Barbour, in 1980, the Bedale jacket was Barbour's first short, lightweight wax jacket for horse riding. And it's still one of their most popular designs. They now make almost a dozen other wax jackets, which all follow the same production process.
Peter puts all the component parts onto the Diablo. Now a Diablo is a basket with little pegs on and will feed on parts to make 5 coats.
Once all the fabric is gathered up, they head off down the production line to be stitched together.
The Diablo will follow round the rail system, going round all the different operations, the different machinists, and then it'll come all the way around to the very end, and that's where you'll have your finished jacket.
First up, it's pockets. The Bedale has 2 bellows pockets, 2 hand warmer pockets, and an internal breast pocket.
So these 2 ladies here both do the same job. This is Lynn and Margie. They put the base lining and the flap on, ready for the pockets going on.
Built for practicality, bellows pockets are made from 4 separate pieces of fabric. The rounded corner design avoids wear and snagging when in use, and needs to be skillfully sewn.
Kerry, which part are you doing today?
Hello, I'm attaching the hand warmers, pocket hand warmers.
And would you say that was a fiddly little job?
As long as I've got it all in lined up and between the lasers, it's all right there. I can do 47 pairs an hour.
That's the hand warmer pocket there, and there's the start of your side. Kelsey, how long have you been here?
2.5 years.
2.5 years?
Yeah.
And Kelsey came from the academy.
The Academy programme gives workers like Kelsey training in the textile industry.
And she's making and attaching the inside breast pocket.
The attached label advises customers how to care for their new coat.
You really should get it re-waxed every year.
Some customers find it hard to part with their much-loved jackets. And the team here are happy to help them last longer, thanks to a unique repair service.
Whatever state your Barbour jacket is in, if you send it in, I can reassure you we can mend it. It doesn't matter what state it's in. If it's savable, we will save it.
They repair and reproof up to 13,000 jackets a year, returning them to their former glory. Even if your dog gets up to mischief, Donna loves a challenge.
He's got his owner's jacket and he's just chewed it to bits. Needs new sleeves, new back, new collar and a new front. She must have really loved that jacket to get it sent in and repaired.
And she's not the only one. The company offered the Queen a free wax jacket to mark her Diamond Jubilee, but Her Majesty said she'd prefer to have her old one spruced up. The cost of having an old wax jacket repaired can equal the price of buying a new one. Back on the shop floor, it's time to add the sleeves. The sleeves of the jackets are sewn together using a double-stitched, rolled seam. This means they're gone over twice to help keep out the rain.
And that there is the sleeve finished, all done now.
Including fabric, it's made up of a total of 160 parts. Some of the features of the Bedale are very specific to the activity it was originally designed for.
The back vent, when it's finished, looks like that. That's actually the back of the jacket. That gives you the flexibility of opening out.
That makes it ideal for sitting on a horse. It takes 60 to 90 minutes to make one jacket.
This is Jean, and Jean's putting the knitted cuff on. Now, Jean's worked for over 30 years, and she's just coming up to retirement in 5 weeks' time. Mr. Banijay.
Oh, Missy good.
Now, all the parts of the jacket are finally coming together.
Christian's doing what we call a join-up. It's joining the back of the jacket to the two fronts of the jacket, and as you can see, you're now forming a complete jacket.
The body of the Bedale wax jacket is now finished. All that's left are the finishing touches, trims and studs.
It's a feature of the jacket, obviously. They have the Barbour signature name on round the studs.
This machine fits over 1,400 studs per hour.
John's well used to these. You can't really take your eye off it at all.
After they're checked for quality, the finished jackets are bagged, ready for the shops.
It makes me feel very proud to work in such a prestigious company that you know a good quality garment is going out to the customer.
We now don't just do jackets, we've branched out into a whole range of different things, but always with the Barbour DNA, always that look like Barbour.
Rooted firmly in its heritage, the Barbour brand continues to grow and develop every year. Stilton. It's been described as the king of blue cheeses. Enjoyed for centuries because of its distinctive strong smell and taste, and the blue veins running through it. Stilton is a protected brand and can only be produced in 6 selected dairies, all located in the English counties of Derbyshire, Nottinghamshire and Leicestershire. And Cropwell Bishop Creamery in Nottinghamshire is one of them, and it's family run. They make 150,000 Stilton rounds every year. Frank Scales established this family cheese-making business in 1941, and today it's run by his grandsons.
We like to focus on making handmade cheese, and that's what makes us different to some of our competitors. We're very lucky that we have so many staff who have been working with us for so many years. One of our cheesemakers has been here over 40 years, and he worked under my grandfather, so he knows pretty much everything there is to know about Stilton.
Making Stilton is a process that hasn't changed for centuries. It begins with fresh milk. The milk arrives at 4 a.m. and is pasteurised on-site at 72 degrees, making it safe for consumption. It's transferred into 2 55,000-litre vats, and it takes 78 litres to make each 8-kilogram round of Stilton. The first stage in making Stilton is to curdle the milk. That's the process of converting milk to a solid.
What we have here is the ingredients for making Stilton cheese. First of all, we have our starter, which is a lactic acid producing bacteria, which gives it its body and texture.
After the milk is poured into the big vats, a live bacteria is added to convert the sugar in the milk into lactic acid.
We then have the Stilton mould, which is penicillin roqueforte, which gives the veining of the blue mould in the cheese.
And by adding billions of spores to the milk, the blue veins that are unique to Stilton and blue cheese can grow. Despite coming from penicillin, it's a natural bacteria that's safe for human consumption. A few hours after the starter and mould have been added to the milk, it's time to add rennet.
Mario is adding the rennet to the milk, which coagulates the milk to turn it into curds and whey.
Rennet is a clotting agent, an enzyme to aid digestion.
At this point now, we just wait for it to coagulate.
The rennet and milk are left for 2 hours so that the mixture can separate into solid curd and the liquid byproduct whey, which is mostly protein. Next, it's time to see if the rennet's done its job and it's ready for cutting. This is the clean break test.
You've got to get a clean break like that. Once he's got a clean break, that tells the cheesemaker that it's ready to cut.
If the milk is properly coagulated, it should break cleanly around the finger. If not, it needs to be left longer. All the cutting is done by hand, in keeping with traditional methods. Knowing the right moment to cut relies on years of experience of cheesemakers like Mario.
Making cheese probably about 30 odd years. Altogether I've been here probably 42 years.
The actual cheese making can only really begin when the curd is fully separated from the whey.
What I'm doing is now is cutting the curd into cubes so it sinks and the whey comes up.
Miss Muffet, eat your heart out. Only the curd is used to make Stilton. But where does the whey go?
We can send that either to the pigs, or in other factories they take all the protein out of it and make whey protein for bodybuilders, or they can take the fat out of it and make whey butter.
The mixture is left overnight to drain.
So here we have a Stilton curd. It's much firmer now than it was yesterday. Okay, it's nice and crumbly, and I can smell the lactic acid in the cheese. The quantity of these vats are 12,000 litres, and we're getting about 160 to 170 cheese.
The firm curds are now ready for milling. They're broken into small pieces.
You've got to imagine that these are like pebbles on a beach, and when they're all put together, you have a void. That void will produce an air pocket where we want the blue mould to grow.
Without the air pockets, there'd be no mould, which is what gives Stilton its unique taste. Next, salt is added.
Salt has to be mixed in evenly. The reason it's done by hand is because you get a good, even distribution of salt through the cheese.
The milled curd is now transferred to cheese moulds called hoops, where it gets its characteristic cylindrical Stilton shape.
And from there, it will sit in that hoop for an hour and a half, and then it's turned upside down to form an edge. And also for that salt and whey to be evenly distributed throughout the cheese.
Typically, cheese is pressed to remove the last of the whey, but with Stilton it drains under its own weight.
So this is the hastening room.
Next, the moulds are stored in a series of temperature-controlled rooms to mature.
Sits in that room for 5 days to allow the whey to come out of the cheese, and it's temperature controlled at a certain temperature to get the right amount of moisture in that cheese.
So what's the temperature, Howard?
I'm not going to tell you too many secrets.
The hastening room holds over 2,000 cheeses, which are turned every day.
So these cheeses are weighing about 11 kilos, so it's quite a heavy job, and it's all done by hand.
After 5 days, they've lost an amazing 3 kilos of liquid whey and can stand on their own. The next stage of the process is called rubbing. The outside of the cheese needs to be sealed. This helps it produce its signature rind. It's totally edible and enhances the Stilton's overall flavour. The rounds are still turned regularly to make sure they keep their shape.
If they're not turned every day, then they'll get what is known as a business an elephant's foot.
An elephant's foot?
It's called elephant's foot because it looks like an elephant's foot. Large at the bottom and narrow at the top. The sheer weight just makes it like a sort of thing.
Now the cheese has developed a hard skin, it's time for that famous blue mould.
So as you can see, this is 5-week-old cheese, which is due to be pierced.
The cheese is pierced with stainless steel needles.
And we put the holes in them to let the air go in them so it starts turning blue. That's been done once, so now we turn it over and do the same again. Yeah, we'd have to reach the centre of the cheese, otherwise you have a core that's got no blue in it.
It's pierced 256 times. Then a week later, it's done again.
Done 343 cheese today. This will be 344.
After 7 weeks, the mould has developed inside, and the Stilton is ready to be wrapped.
This end of the process is called crading.
From the farm to this final stage takes between 8 and 10 weeks.
So what we do, take a sample out of it, we look at the colour, it's nice and yellow and creamy, look at the texture, look at the openness and the blue that's grown inside that openness all the way up to the side. And if we assess that, that's okay cheese. It then goes back, and to see that we've got an even spread of blue throughout the cheese, we iron it at the bottom as well as the top.
Every single Stilton is assessed before it leaves the creamery. And if it's not up to Howard's standards, it's not going on sale. Traditionally, Stilton was made in the summer months, when the local pasture was at its richest. And the rounds matured in time for Christmas.
Well, you can eat Stilton in many ways. I like it with some honey or with some crusty bread. I like to drink with it sparkling wines. Some West Country cider is a really good alternative as well.
It's so good to see the finished product, a prize-winning Stilton.